So hello again everyone. Since Mr. Osama introduced me, so I will not do that again. We can start directly with the content. So for today's tutorial, it will be not exactly a tutorial running Unreal. It will be also a presentation, since if I want to show you all the professional stuff and the advanced stuff in Unreal, it will be hard to run it in real time. So most of the stuff is recorded or I am taking screenshots. I'll start first by giving a quick overview about Unreal. Then I will give a quick introduction about RRLab, where I'm doing my PhD. Why is that? Because I have to talk about the Autobus, which is my project I'm working on. And it's also what I will be doing the simulation for. So I will give a quick overview about the Autobus itself. Then I will talk about two important assets, Blender and Marketplace, and how we can use this to import models to Unreal. Then I will show you the steps I took while creating the environment in Unreal for the university campus where the bus is driving. Then I will show you also RRLab plugins that we created in our group. These plugins are just to simplify the use of sensors and adding pedestrians to the scene, and you will see what this is doing later on. Then I will talk about the blueprints in Unreal and why they are necessary. Finally, I will end with the machine learning with a tool that is introduced to Unreal since a year now. It is called Learning Agents. I wanted to add it to the presentation, so I took just 1 week before I came here to Pakistan to play out with it, but I see it's really important to discuss it as well. And finally, I will be running the simulation and I will show you what results I can get. Okay, so quickly an overview about Unreal. Unreal is a high-level game engine used for gaming. So it was officially introduced for creating games, not for simulations. But as we can see with games, with every update or every new version, that we get more realistic visualizations in games, and that's why researchers found out that okay, we can use it to create realistic simulations. So it has a growing role in robotics and autonomous vehicle simulations, since also it has the physics is improving by every version of Unreal. Why we use Unreal Engine for robotics simulations when we also have some other simulators that are created and developed for robotics, such as IsaacSim or Gazebo, for example. And here the important point is that when we are caring much about the to have a realistic visualization, then Unreal is the best option in this case, because as I mentioned, it is being created and developed for gaming, and as we can see, gaming is getting advanced and more realistic visualizations. So since I'm using, for example, camera in my simulations, it will be necessary to have realistic environments as well. Also, it's more flexible, because in other simulators, they are created for robotics. So if we want to create, for example, human models or something like this, we will not have the same realism we have in Unreal. It is not in IsaacSim and, for example, Gazebo, it's just done for robotics. Also, we have real-time rendering and physics-based simulations. For this point, I know that IsaacSim is better when we are talking about physics-based simulations. However, what we have also on Unreal is quite good for running our own simulations. And finally, the blueprint system, which is in Unreal. It allows non-programmers or people who have very few knowledge of programming with Python or C++, they still can create complex and advanced simulations in Unreal. They don't have to know much about Python or C++ as in other simulators. And you can see down on the left what a blueprint looks like. So we have this node-based system, which are like some blocks. These blocks can be, for example, to set variables or, for example, to read from a variable. We can do a lot of logic using these blocks without knowing much about programming. And also we'll see more examples later on. Here is to show you how different simulations look like. So with IsaacSim, you can see we can have robotics and many models, but the simulation in Gazebo and IsaacSim, they are not as realistic as what we have here, as you can see down in Unreal. So quickly I will introduce RRLab. There's a robotics research lab in the University of RPTU in Kaiserslautern in Germany. The head of the group is Professor Dr. Karsten Burns. He'll also be giving a talk today and a presentation tomorrow. The focus of our research is on indoor, outdoor robotics, simulations, and humanoid robots. Here you can see some of the robots we are working on in the lab. And what I'll be focusing on is the Autobus, which I'm doing my PhD and research on, and what I will be also showing into this simulation. Here are just more robots, and you feel free to visit the website if you need to get more information about the robots we have in the lab. Okay, so with the Autobus, the bus itself was bought from Compay Robotics. It is a French company from France. When it was bought, it was driving manually. It didn't have any sensors or computers mounted on them. The research was focused on like the main goal is to drive this Autobus in pedestrian zones, so zones that have no other vehicles. And this you can see on the image on top right. It is used to facilitate transportation for elderly people in these pedestrian zones. Also, it's important to notice that in pedestrian zones, the vehicles are driving maximum speed with a maximum speed of 6 kilometers per hour. So it is not that fast. The main research also in this topic is human-robot interaction. So we would like to the bus to be able to communicate with the pedestrians, and the pedestrians to be able to communicate as well with the robot itself. Some of the sensors that was included are stereo cameras, safety scanners, 3D lidars, and GPS. It is hard a little bit to see here. They are mounted on top. This here is the laser scanner down the bottom. We have one in the front and in the rear of the vehicle. Also, the system was equipped with a safety certified equipment for safe stopping, which is 6 system. And this is just to add a layer of safety on the bus. If everything went wrong, we still want to ensure that it is safe to drive around people. There's another image for the bus and the placement of some of the sensors. You can see them here. Okay, so with Blender and Marketplace. First of all, I will introduce Blender. This is an open 3D modeling software. Again, it was used not for like for simulations and that stuff. It was created mainly to make realistic animations. So it is used in animations, creating animations like cartoons and this stuff. Also, it is greatly used in advertisements. So these advertisements we see on TV, it is also created by Blender or software similar to Blender. So it's actually so professional that we can get very realistic models with it. It's ideal for creating custom assets like vehicle, characters, and environments. These 2 images down, you can see they are also created by Blender. We can have realistic environments. A vehicle like this human model, for example, it's all created by Blender. This much realism we don't also exactly need in our simulation, because if we have something so complex like this, we will also need a lot of computing power when we run our model. So this is just to show you how professional we can reach with this softwares and how realistic we can reach with these softwares, but we don't need that much the advanced or professional realistic visualization. It was created, I created the Autobus model on Blender. So this is also what we will see later. I was just playing around with Blender. So this model I created on Blender. You can see here how detailed the image, the model can be. Something like this also, as I mentioned, it requires a lot of computation power to run. So yeah, you can see the texture, a lot of different materials, and the lighting as well. This is just a robot I was playing around, and I was creating just a model to play around with Blender. So even here we can run a simulation, an animation like this. Yeah, so something like this can be created by Blender. Also, like in Blender, to create everything by ourselves, it will take a long time. So what we can use Blender for is, for example, if I have a bus that is not found in a place anywhere else, it is hard to find a model online. So I will create this on Blender. But if we have other assets that we need to add to our environment, we don't have to create everything by ourselves. Trees, for example, grass, this stuff. That's where Unreal Marketplace comes into play. This Unreal Marketplace is the most popular website used by Unreal users, but there are other websites which we can download models from. Assets includes including characters, buildings, and roads. And we can see here, for example, we can download assets such as this tower or the vehicle. We have also some trees that we can download. We can even have full environments such as this train station, and the last one is a power plant. So we can import this stuff directly from Unreal Marketplace, and we can use it in our simulation.
Maybe can you also change it, modify it from the original what it looks like, and make maybe a bit modified according to your own?
Yeah. So, for example, if we get an asset like a tree, we can change its size, we can change the rotation of the tree, stuff like that. If we have an environment, we can change the placing of items in the environment. So, for example,
not more. I mean, you can not change the whole shape of it. Huh?
You can change the shape. Yeah, but on Unreal we are not playing exactly with the model. We import models from outside. So, for example, we can take this model into Blender and change something with it.
This is only in the case that I'm asking, because, for example, in some cases you don't find exactly what you're looking for, but you find something very close to it.
Yeah.
From the marketplace, you bring it and then you modify it. They modify the model.
Yeah, modification can be made on Blender. So other softwares like Blender, SolidWorks, or Fusion 360, these applications we can use to play with the model itself.
But this marketplace items can we can we bring it in the Blender?
Yeah. So we have these models like they can be like FBX files or something like this. So we can import it to other applications and softwares.
And are these models publicly and freely available, or are they to be purchased from the market?
Some of them are purchased, for example, mostly with environments. So when we have like a train station environment, you will probably find it paid. But other assets like trees and this stuff, you can find it for free.
And do you only find builder compatible models in the Unity, so the Unreal Marketplace, or are there any other platforms as well?
There are other websites. I was using also like this for 3D printing websites like 3D Cult and that these websites. They can be used to also import some models to Unreal.
And you can also this marketplace also not only have the models, for example, for trees or environment, but could also contain some animals or models of animals or human or some biological agents.
So you can also have humans, like for in our case we downloaded human models, and then we to have pedestrians in our scene. So yeah, we imported also some human.
Okay.
And there are also other websites which are more specialized in this to import humans. Megascan, I think it's a website that can be used for something like this. Okay, so this is the model I created in Blender for the Autobus, the one on the right side. And on the left side is when I imported it to Unreal. We can see on the right side it doesn't have the sensors added to them, but then on Unreal they are suddenly there. And this is what we agreed on in our group, that we want to have the places of the sensors defined in Blender, but not the sensors themselves. We want to import the model to Unreal, and then in Unreal we can spawn the sensors. We will know exactly their positions and the locations, but we will not add the sensor directly in Blender.
The physics of this whole thing also cater in the Unreal, right?
Again?
The physics of these models is covered in the Unreal.
Yeah, so we add...
Not in the Blender. Blender you just make the model.
We create the model itself in Blender, and then we can add, for example, collisions and this physics-based stuff in Unreal. Even like the weight of the vehicle, the braking and that stuff.
Also, I wanted to ask this question in the end, but since Dr. Will already asked it, so I'll just go ahead. You mentioned that Unreal and Blender are very realistic visually.
Yeah.
But are they very realistic in terms of their physical engine as well? Like the way materials interact with each other? Are they very realistic in terms of that as well?
Yeah, so for Unreal, it's like the physics model is actually good enough. As I mentioned, also like Isaac simulation is better when we are dealing with robotics physics, but Unreal is good enough for us for our use case. Yeah. And you can see this also in games, like how if you compare with games, you can see the physics, how good it is. Okay, so as I mentioned that we agreed in our group that we will add the sensor positions on Blender. This is done here, as you can see, with what is called bones in Blender. Bones are like we place these bones at the wheels of the vehicles, and also at the sensor locations. For the wheels, this is required by Unreal because we can, when we import the model to Unreal, Unreal can directly make the vehicle move. How? It is by defining these bonds. We need to define where these wheels are. As for the other sensors, we have these sockets, we have these bonds, which when imported to Unreal will be called sockets. So this socket is just a place, like a pointer, and then we will, when we import to Unreal, it will know which sensor to add into which socket. And this is defined in a configuration file that we'll also see later on. So yeah, just what's important here is that we have to be careful also about the axes. We have different axes in Unreal and Blender, so we have to define them in a certain way that the x-axis should be the axis that is pointing in the front direction for the sensor, or for example here for the vehicle. So it is not actually exactly clear, but we have it here. That is the x-axis, which is pointing forward. Then we have the z-axis, which is pointing upward. This is for the sensors and for the vehicle as well. If we define it in a wrong way, for sure the vehicle will not work correctly in Unreal when we import it. If we want to import to Unreal and export from Blender, we have different settings that we need to keep in mind. Also, it is hard to see from your face. What we need to be careful about is the mesh and the armature. So the mesh is for the body itself. The armature is for these bonds that we added. This is what we need to export. Other items are not important, such as camera, lamp, and others we don't need. Also here we need to take care of the transform. So we define that the x-axis will be the front, and then the z-axis is the upward, the up direction. This we have to as well define it here. And then the end is apply transformation. What else we need here? That's it. If we have an animation that we created on Blender and we want to import one day, we can do that by making the animation. But in our case, all the animations were created in Unreal, not in Blender. Yeah, and then on Unreal side, we have to import the mesh up here. So we have here on Unreal that we have to import the skeletal mesh. This is again is the bones that we defined, and import the mesh, the body itself. Here, if we have any animations from Blender, but since we don't have, we don't need to import. And convert the scene. So this will take care of the axis that we defined in Blender. So the goal of with the simulation is to create the environment for the campus and the bus model for the simulation. So this is how the campus looks like with the drone. And now I'll start talking about the steps, what steps I took to create this environment. First of all, when we start with Unreal, we start with an empty space. I started with creating the terrain for the campus. And to create this terrain, we have I imported the data from OpenStreetMaps. This have like a depth map that you can see on the right side. This is called the depth map. It's a black and white image. The white parts are areas with higher altitude, and the black areas are areas with lower altitude. So we can import this data from OpenStreetMaps, and then we can import it into Unreal, and it's called an Unreal height map. When we import this image directly to Unreal, it will create this terrain that we have on the left side. So this is a material I just added to help you see how the terrain looks like. Originally it's black, so it will not be visible. So yeah, this is the terrain creation part. After that, the addition of buildings. So to add buildings, I imported the data from Google Earth. We can import these footprints, and you can see that they are placed on the terrain in a nice way. So this is all done just by importing the data. I have not done much in this step. You can see that the buildings are sitting on the terrain. Yeah. The thing is, the buildings doesn't have any texture or any images to them. They are just some blocks. The next step was to add different materials to the scene. So the original scene had just grass or this green material. Then I started to add some different material like this dirt over there, yeah. And then you can also see just a closer view for the placement of the building on the terrain. And in this step also I started adding the other items such as the trees, not the trees, such as, for example, traffic lights or chairs or something like this in the campus. The next step was to add foliage. So in Unreal, there is a foliage tool. What we can do here is that we can import or download the models from Marketplace, for example, the trees, the grass, and other items. What I did was to download different variants of these objects. So for example, we have one tree, we can download 3 or 4 different variants. And then what we can do with foliage tool in Unreal is that it can randomize these different assets. This will create more realism to the scene. So we will not have a copy paste for each item. We can have trees with different scales, different rotations. And since I also downloaded like 4 or 5 different variants, we will have different tree variants in the scene. Then this step was to add the texture to the buildings. So this step was from another student's project where he took images for the buildings in the campus. It was required for his project. So I used these images to add the texture to the buildings that I downloaded from Google Earth. And this is how...
Taking the picture in the camera or using some...
With the camera. Directly with the camera.
Not from any of the...
No, just with the camera. It's so simple. And then, yeah, it has to be taken in a... Like the perspective has to be correct.
But
That's
then how many pictures you can take?
Like what we need here, for example, for this building was this side, as you can see. Like it's based on which sides you can take images for. Yeah, so I don't have exactly images for all the sides and exactly, yeah. So when you see now, it will not be in every side. Like here is the campus, how it looks. You can see, for example, for the Mensa building, there is no images available. But yeah, like for example, this side it was there. Yeah, what was visible, what was available, I just used. Yeah, sure.
So the images you get in the standard JPEGs is not some sort of special scanning format.
It's so simple, yeah. It's just
We can just convert a JPEG into images.
and you have to like play with it a little bit, move it to know where to start and where to end the image.
You can also, I think,
Extend.
sketch it
Yeah,
so that it can fix according to what it is.
that's right. And this step can be done also in Blender. So we can do this either in Blender or Unreal. In Blender, I believe it's called wrapping. So there is a tool specific for wrapping the images. Okay, so now let's talk quickly about the RRLab plugins that were used. We have Sensors plugin and Pedestrian plugin. Starting with the Sensors plugin, in Unreal, when we want to add, for example, a camera or any other item, we can have an actor. So an actor is like the base class, and then we can parent, like it can be the parent, and we can get some child from this parent. We have the sensor parent. This is what we created. And from that also we have different models for the different sensors, yeah? So this simplifies that if we want to create a new sensor, we can just change some parameters to have different variant of sensors. What we have is, for example, the scene capture sensor. We have generic camera, 360, and for example, a stereo camera. We have other sensors such as GNSS, IMU, and distance sensors.
Basically, this sensor gives us the data as well, or this is just how to create a sensor?
It will also give the data.
It will also give the data in the simulation world, right?
Yeah,
In the simulation environment.
yeah, we can read from it.
And, for example, for the depth images, the sensor would be different. For RGB, this is different. So how it shows that that the data that we are looking for is the specific one.
So you mean, for example, we would like to have depth data,
Let this one.
then we'll use this generic stereo. So it's a stereo camera.
So this is you guys made it, or
Yeah,
this
yeah.
is also available in the.
No, we created. So we
You
create
created
this.
yourself. Huh?
Yeah. So you can, like, there are also visible, other stuff online that we can import from. Like this is what we did. We get some models from somewhere else, and then we just start playing with the values and the parameters. Yeah. Because we can use a sensor that was made for another other application in ROS or something like this,
Yes.
not for Unreal, and then we can just change parameters out of it.
How many sensors do we have in this year?
So here are the sensors that we define. We have different cameras, different GNSS, inertial sensors, So we have a couple of different sensors. So yeah, this is the files we define them in C++, and then we can import them to Unreal. And this is the robot config file that I was mentioning, that we created the sockets in Blender before. How Unreal will know exactly which sensor to place in which socket, this is what we define here in the config file. So let me go out just to, okay. So we have, for example, the safety laser scanner, which was in the front of the vehicle. These are just names. It's not that important. It will be what we see on Unreal, these names. Then we have the sensor class, which we define with the code, the sensor class, if we enable it or not, and then the socket. So this socket is what we named in Blender. So this name is important, yeah. Then if we have to apply any transformations to them, but we already did this in Blender as well. We don't want to play with these values later on.
Does it, what this is this type of values, or what does it sense basically?
So this is the safety laser scanner. It will give us point cloud data for
Only point cloud?
in one axis. I mean in two axes, not in the Z axis. Okay, so here also are some parameters if you would like to change something, or the focal length if we have a camera, for example, field of view, and that's this stuff. Okay, here are other sensors. There are also some other libraries for object detection or something. Yeah, so these were created in the group. Also, sensor spawning is what we use in Unreal to start spawning these sensors onto the vehicle. Okay, so here from the plugin, the sensor plugin, we can see, for example, the left side. This is what we see from the scene in the simulation. In this part, for example, there are pedestrians, and yeah, you can see the environment. Then this is what we can get. These are the data we can get from these sensors. So we have the camera. After that, I applied just segmentation to see how good it can be, and you can see it is quite accurate. Also the LiDAR. So this is what we get if we have a LiDAR mounted on the vehicle. This is the point cloud data from the LiDAR.
So if I understand it correctly, you have to basically build a sensor in virtual environment in simulation.
Yeah.
And it should be working exactly similar to what it should be working in a real.
Yes. Which for sure will not get exactly, but it will be like,
yeah, and that's very important that if it's not working correctly, or it's a bit different than the real world, then if you go in, or we should take this whole data that you also mentioning there and try to mix it with the real world data. It might be a problem. It will not forget if you are doing some learning class.
Yeah, even like it's important about the orientation and the placement of the sensors. So the orientation is also important. Yeah. Now about the other plugin, which is for pedestrians. This is not like a very important plugin. What is this used for? Like the normal case. We can download the assets or the human characters from Marketplace, for example, and then we can start placing them on our scene. The thing is, we don't want to just add one or two characters. We would like to have a lot of different variants, yeah? So, and also we can change the characteristics of the characters normally. Like when we download from Marketplace and we import it to Unreal, we can, for example, change the skin color, the hair color, maybe the clothes of the person, like the color of the cloth. This can be done manually. But what we did with the pedestrian plugin is that we made it easier to add different variants of these characters. Yeah. So we will have, for example, 5 different characters. Using this pedestrian plugin, we can create groups. So, for example, a group of 20 people, another place with a group of 50 people. This can be done easily with the pedestrian plugin. And also it will create different variants of these people. So different colors, different hair colors, different, maybe also the scale. So this stuff we can do directly. Yeah. So when we installed, when we download from Marketplace, they even come with different animations. So they can walk, for example, run, jump. These actions are there already. And then also using the plugin, we can randomize these actions. So a character can be standing and suddenly he will run. This is done with the pedestrian plugin. This will help to have like different random dynamic environment.
If the main purpose of this is not dynamic obstacles, why not just use cuboids that move around? Why does that be a human movement specifically?
And this is a nice question because, as I mentioned in the beginning, we use this for human robot interaction. So it was important for the research to understand what the human is doing. So he is calling on a phone. We want to record this. We want the model to understand that he is calling on a phone. He is looking at the vehicle or not. So this is important for us to have this scenario.
So the idea also is to get the simulated data.
Yeah.
And this looks close to what it should
In real
look
life.
in the real world.
Correct. And with machine learning,
If the cuboids are running here and there might not be too good for if you want to do some sort of classification in the simulation and try to apply it in the
like when applying, for example, reinforcement learning or something like this,
Exactly.
it will not be beneficial to have obstacles that doesn't look like real life. Yeah.
So I have a question.
Yeah, sure.
If we have some specific spatial temporal human movement patterns and we create characters over here, can we somehow load those spatial temporal movement files into this and then embed them with the characters over here so that they perform the same actions that we want from them?
Yeah. So in Unreal, you can define when each action should start and when it should end. Yeah. Using this pedestrian plugin, it just simplifies this. So it will make random movement. For example, you don't know what will happen.
But
Like-
can you customize it?
Yeah, you can customize. You mean the animation?
Because the gestures are coming with whatever
Mhm.
is there. Can you make it more?
Yes.
Can you do it on your own? What you think?
Yeah, we can do this.
For example, if I have some file that consists of human joints movements.
Mhm.
Can I take that saved file into this particular software and pass or do something so that the person or pedestrian that is over there, he's or she is performing the exactly same movement that I have given through a file to the enthusiast system. So that will be customized movement. For example, if
customized
I want
movement,
them
yeah.
to perform the sign for hello,
Mhm.
and that is not already present in the
Yeah.
file. So can I do that?
We can do that. I know for sure we can do that in Blender as well. Like the different animations, this is what we create. We create different animations. So we can create this movement on Blender.
Yes.
With pedestrians, I didn't exactly work on this. Like I didn't change the gestures. I'm using what is already there. But for example, for the bus I had to create the animation to open the door and close the door. So this animation I created. So yeah, we can play with the different animations. Also, the characters come with different, like the skeleton, so you can see the joints. You can play with them. Yeah. Here is just a quick short video for one of the pedestrians, what actions they can do, like just moving around. Yeah, so something like this human character, it is hard to create something like this in exact simulation or in Gazebo, for example. That's where Unreal is better. Yeah, and later on in the simulation, I think you will call. Yeah, so some actions like this. Okay, now let's talk about blueprints in Unreal, which is a very good advantage in Unreal, and it's a powerful tool. It's Unreal Engine's visual scripting system, and it, as I mentioned, it allows people who are not professional with programming to create complex logic in the simulation without having to know much about coding. It's a node-based interface where you can connect different functions and logic blocks visually to create gameplay elements, interactions, and more. With blueprints, we can create the different actions. We can create how the vehicle is moving. We can import, for example, the sensor spawning code that we created in the lab. We can run it in the blueprint. So we can do a lot of stuff with a blueprint. You can see here. These are some stuff I did with the blueprint so far, like the bus movement logic. So which button to press that will let the bus move, which will let it brake, how to steer. These things can be defined in the blueprint. Also the door mechanism, how the door opens and closes, creating this animation. And then I can play with the animation in the blueprint section. And the last part is the reinforcement learning with the learning agent, AI agent, which is the plugin that we'll talk about in the end of this tutorial, which is used for machine learning. Blueprints were used to design the interaction framework for reinforcement learning. Yeah. So here is just a simple blueprint that is controlling the logic for the door opening and closing. We can see, for example, the red part, this is the actions. Here is the animation itself. So this is the animation is created, and then here we can do stuff with this animation. You can see, for example, the action, if we press a button, the door will open. If we press another button, the door will close. And like if you read this, you can understand. You don't need to know much about programming to create these blocks and to understand these blocks. So we have, for example, two actions. When we press, in my case, it was O button. If I press O, the door will open. We are controlling the door because the doors are two like sliding doors. So each one of them was controlled separately. So the left one and the right one. And then if we press O, for example, both of them will move. If we press P, both of them will close. And here is just setting to which item we are giving this animation. So we're giving this to the left door. We define this in Blender as well, that this is a door, left door, this is named right door. So these are already known by Unreal. And this is a more complex blueprint, just to show how complex it can be, or how much we can do with this blueprint tool. So here is just the logic of all the vehicle I had, what Bluetooth to use, some logic of starting the sensors, to spawn the sensors. All these blocks are just defined here in the blueprints. Nothing more was done in program language.